Once again, welcome back. After a long time, here we are going to discuss another important and vital class for you, right? And over the concept of set theory. In the previous class, already all of you know, and we have discussed the introduction to set with the different examples and also types of set. Okay, and this is the class I am going to discuss another important concept of the set theory, which I am going to discuss for you of your class 11 mathematics, based on the concept of operation of set theory, and which is the vital concept, important concept, which I have put my hard work to prepare this class for you, which I am vividly, and lucidly explain what is the operation of set theory and what are the different types of operation of set theory with vital theorem, vital statement, important statement for you. So I hope you will develop your patience, interest and eagerness to watch the class, and I will be delighted after watching the class of your suggestion, feedback, comments, which is a kind of motivation for me to prepare further more and more class like this for you. And here in this class you have to watch, because this is the class where you have to face the different kind of problem in futures in your competitive exams, and without which it is not possible for you. So the operation of set theory is one of the vital concept and important concept for you of your class 11 mathematics, which I am going to discuss. So let's start. Yes, let's see. Here in the first concept I am discussing what is operation of set theory. What is operation of set theory, dear students? And all of you know, in binary operation in algebra, what are the operation? Algebraic operation. Algebraic operation means mostly, and all of you know, and we say that is the addition, subtraction, multiplication and division. These are the four operators which entirely modulating, controlling the algebraic operation. Similarly, the operation of set theory is also the another vital concept, which is controlling the interaction of the set, combination of the two sets, two or more sets, and which gives rise to the formation of new sets. Operation of set theory, and here I am going to discuss. The set operation can be defined as the operation that are performed on two or more sets to obtain a single set containing a combination of elements from both the sets. The set operation is a formation of new sets due to interaction and combination two or more sets by taking the elements from both the sets. That is known as operation of set theory. As you know, the algebraic operation is the addition, subtraction, multiplication and division of the numerical expression, algebraic operation, algebraic statement. Similarly, the set operation is also is a combination of two or more set in order to bring an formation of a new set, resulting in a new set. So set operation is performed on two or more sets to get a single set by combination of elements according to the operation performed on them. What kind of set operation? According to the operation, we are going to formation of new set due to combination of two or more sets. So set operation is the formation of new set while combining two or more sets, in order to bring a new set for you, right? So here I am going to discuss the types of operation of set. As you know, the addition, subtraction, Multiplication and division are the algebraic operation are the four operators, important operators, entirely controlling the algebraic process, algebra in mathematical any mathematical activities. Similarly, this type of operation, these are the following operation which I am going to discuss, is entirely controlling the interaction and combination of two or more sets between them. So here, what is types of operation? What type of operation of or types of operation of sets? In this class, I am going to discuss. So mostly there are 5 important basic operations of the set theory. First one, we have to discuss the union of set, set union. Second one, we are going to discuss the intersection of sets. Third one, we are going to discuss difference of set. Fourth one, we are going to discuss symmetric difference of sets. And fifth one, we are going to discuss complement of sets. And in this class, we are discussing the set union and their properties, important statement and theorem, and which I am going to discuss and vividly along with the Venn diagram. So nicely the class is going to be prepared for you, and I hope you will take interest, because these are the most important. Without these operators, and you cannot proceed the knowledge of set theory, without which the knowledge of set theory will be incomplete. Understand? And any kind of problem and you are going to solve based on the concept of set theory, so these set operations are most vital for you. Okay? Understand? Let's see here, first of all, the union of set. What is the set unions? Union of set. Right? So what is the set union? Union means combination. The union of sets, two sets A and B, is set C. When you are combining two sets A and B, and it gives rise to the formation of another set, single set, a new set, that set is C, which consists of all the elements that are either in the set A or in the set B. Symbolically, the union of sets A and B is represented as, we can write A union B. The symbol stands for union. Sometimes the symbol universal set, sometimes you know all of you, and the symbol also we can use sometimes. This is the symbol stands for universal set, but this in set operation the symbol stands for union. Okay, which is the combination of two sets A and B, or more than two sets. So A union B, this is known as A union B. We read as A union B. Okay, and we can represent in the builder methods A union B, which is equal to X, such that X belongs to A or X belongs to B. Clear? Understand? So this is the builder methods. In the builder methods, we can represent the union set of A and B, A union B, which is X, such that X belongs to A or X belongs to B. Right? Understand? So thus, if two sets A and B are given, the union of sets A and B is equal to the set that contains all the elements present in the set A or in the set B. Okay, we can write the set A or in the set B. Understand? See here, and this symbol, the union of set is a set which the formation of the combination of sets A and B, that we have to make the such a set, the set another set, and by taking of the set A and B, and that by taking all the elements that present in the set A and in the set B. So this operation can be represented, already we discussed, A union B, which is equal to X, such that X belongs to A or X belongs to B. So here OR means what? Here the meaning OR means, this is the operator, and what is the meaning of that? It means that if X is the element of the set A union B, it means the X may be the element of the set A, or X is either present in the set A or is present in the set B. Right? Understand? Or X may be present in both the set also. Is it clear? The operator OR is union is stands for the union set, that it is indicates that the element may be in the set A or may be in the set B or maybe both the set. Right? So here X is the element present in both the set A and B, or either in the set A or in the set B. Is it clear? So let's see with an example. Example of union sets. Okay. Suppose if the set A is equal to 1, 2, 3, 4, 5. A simple example I am going to discuss. Suppose A is a set containing the element 1, 2, 3, 4, 5, and B is another set which contains the set what? B is a set we taking, okay, and B is a set having element 6, 7, 8. Now let's see A union B. A union B means we have to take all the elements of the set A as well as the set B, right? Okay, so 1, 2, 3, 4, 5 union 6, 7, 8. Thus we shall get the union of the sets is A union B, which is 1, 2, 3, 4, 5, 6, 7, 8. This is the okay, the union set of A and B. Okay, so understood? Very simple. We have to take all the element of the A and all the element of B, and by taking all the element of A and B, we have to write in the curly brackets, and that brings out the formation of the another set, and that set is the known as A union B. Okay, understand? Very simple. Okay, let's see here. What is the Venn diagram of the set union? With the help of Venn diagram, we can explain also, right? Suppose the set A is equal to 1, 2, 3, 4, 5, 9. Another set B is 6, 7, 8, 9. So A union B we shall get. Understand? So A union B we shall get 1, 2, 3, 4, 5, 6, 7, 8, 9 by taking all the element of A and B. So let's see how to write in the Venn diagram. This is the Venn diagram of A union B. Here you see U stands for, this is the U stands for invertial set. Sometimes please don't confuse in the union set. It is also, this symbol also we can use sometimes the union set, invertial set. Understand? But the set union, and this is known as the set operator. Okay. Now here is the set A and B. Here A union B. This is the A union B, right? Understand or not? So A union B, we have to take the element. Let's see, and it contains the set element. So A is the element what? What are the element of the set A? That is 1, 2, 3, 4, 5. You see the element 6 is an element of the set B, 7, 8 and 9. You see here the 9 is an element, is the present in, okay, the present in both the set. Yes, here this present in both the element. 9 is the element of both the set. That's why it is written in the intersection portion, the common portion, right? So this is the Venn diagram of A union B by taking all the element 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the Venn diagram for you of the set union. Understand? Okay. Let's see here another set. If A is a set having element A, B, C, D, and B is an element, B is a set having element D, E, F, okay, and C is another set whose element G, H, K, the 3 set. We can take the union of more than 2 sets also, okay. Understand? Here find A union B union C, and this is the combination of 3 sets. We are taking the union of 3 sets A, B, C, okay. And here according to definition, the union set means all the element of A, B, C can be taken in the, while you are formulating formation of the union set of A, B and C. Let's see the Venn diagram here. Understand? Here if you see by A union B union C, what are the elements are here? A, B, C, D, E, F, G, H, K. And look at the Venn diagram here. Here it is the set A, set B and set C. Okay. Understand? And here the element of the set, here you see the element. See what kind of element of the set A? You write A, B, C, D. And here the element of the set B, E, F, yes, D. And here this is the set C, and his element are G, H, K. Understand? So if all the elements are taken, okay, and these are the element of the A union B union C, we have to take all the element of the set A, B and C. Is it clear? Yes. So this is the A union B union C. Similarly, the properties of union set. What is the properties of union set? First property is that commutative property. Commutative law. As you know, the commutative law of addition, subtraction, multiplication, division in algebra, similar process in the set theory also, we can use the commutative property. We can add two sets in any order. Okay, when the two sets undergo union in any order, their resulting set remains same. The resultant set will remain same. It means that the union sets obey commutative law. In mathematical term, we can say that A union B is equal to B union A. Okay, the set union obey commutative law. Is it clear? That we are going to prove it. Okay, it means when the two sets can be undergo union in any order, the resultant set will remain same. Okay, this is one of the important property, and we can prove it, we can verify it. Okay, let us see how to prove A union B is equal to B union A here. By taking examples, we can prove it by examples, by using property and by using Venn diagram. Three methods are there, and here I am going to prove it. A union B is equal to B union A by taking the examples. Suppose A is a set having element 1, 2, 3, 4, 5, 6, and B is an element having a B is a set having element 5, 6, 7, 8, 9. So now you see we have to prove LHS, left hand side A union B. So the element of A union B will be the set of all the elements of A and B, and you can see the A union B. Okay, what are the elements? 1, 2, 3, 4, 5, 6, 7, 8, 9. All the elements of the set A and B. Okay, can be taken to form A union B. Understand? Let's see once again. Similarly, we have to find RHS, right hand side B union A. Here the first set is B, second set is A. So you have to write the first set B. The element of the first set B is what? 5, 6, 7, 8, 9 union. Second set 1, 2, 3, 4, 5, 6. So you see similar process. We can take all the elements of the set B and A to bring out the formation of B union A, and you can clearly see, and in both cases it is clearly understood that both the set A union B and B union A having the same element. Thus it is understood, it is proved that the A union B is equal to B union A. It means the set union obey commutative law. Okay, and it is also another alternative methods using property. I have done it by using property. How can you prove A union B is equal to B union A commutative law? We know that if A is a subset of B and B is a subset of A, then A is equal to B in the previous set. Yes or no? So if you can prove that A union B is a subset of B union A and B union A is a subset of A union B, then you can prove that A union B is equal to B union A. Is it clear? Understand? So let's see A union B is equal to B union A using property methods, using builder methods by taking the element X. Okay, we have to prove it. Suppose let X belongs to A union B, and if X belongs to A union B, then if X belongs to A, then X belongs to B according to the subset, because A is a subset of B, right? So X belongs to B or X belongs to A, we can write. Understand? Then X belongs to B union A. It means X belongs to A union B, then X belongs to B union A. It means A union B is a subset of B union A. Understand? Okay. Since X is an element of A union B, then X may be an element of the set A, or then X must be element in the set B. Then, or you can write if X belongs to B, then X also, or X belongs to A. Okay. Then X belongs to B union A. Understand? Since X belongs to A union B and X belongs to B union A, thus A union B is a subset of B union A. Okay. Similarly, we can prove it. Let X belongs to B union A. If X belongs to B union, X belongs to B, then X belongs to also A. Right? X belongs to B union A means X belongs to B, then X belongs to A. It means X belongs to A or X belongs to B. X may be an element in the set A or in the set B, because union set, the element in the set either in the set A or in the set B. it means X belongs to A union B. Thus, since X belongs to B union A and X belongs to A union B, also this is clearly understood, so that B union A is also subset of A union B. Understand? Okay. So from both the cases, we clearly that A union B is a subset of B union A from the point 1. Again, B union A is a subset of A union B, point 2. So from both the cases, it is clearly understood that A union B is equal to B union A. It means using the property method, and it is also proof the set union set obey commutative law. Understand? And also we can use the Venn diagram to prove this. Okay. Let's see A union B. The element A is a set and B the here we have taken the A set and B set, and here is the set A union B element, and in this process we can find the Venn diagram, how to find the union set A union B. We can prove commutative law under union set. Okay. Here two sets A and B. Now write down the element of the set A and B in the Venn diagram. These are the element of the set A, yes, and these are the element of the set B. Clear? So A union B, you see all the element of the set A and B we have taken to bring the formation of A union B, right? Understand? So let's see more clearly the A union B. The shading region, the shading portion, the shaded portion which covers the entire parts of the set A and B. Okay, the part of the region of A and B entirely taken considered. Okay, as A union B. This is the by shading portion, shaded portion of A and B. Okay, also clear that it is the Venn diagram of A union B, which is the part of entire part of A and B. Okay, understand? So A union B is the shading portion of A union B, right? Okay, all the element of A and B. It is clear the shading region indicate that we have to take all the element of A and all the element of B to bring the formation of a new set that is known as A union B. And from the Venn diagram also it is clearly understood, right? Okay, understand? Okay. Similarly, B union A. Let us take first set B, second set A. Let us write the element, and 5, 6, these are the common element which are present in the set A and B. Here 7, 8 are the element of the set B. Okay, 9. Similarly, these element of the these are the element of the set A. So B union A, we can take the B union A which by taking all the element of B and element of A. Understand? Same element contains, right? Okay. From both the cases it is clear that we see the B union A is also by taking the set B and A. Okay. Let's see the shading portion, the shaded portion, the shaded region indicate that we have to take all the element of B and A to bring out the formation of B union A. See both the cases A union B and B union A give the same Venn diagram, and from the both Venn diagram it is clearly understood that A union B is equal to B union A. Thus the union set obeys commutative law, and which has been proved by Venn diagram. Okay students, yes, right, look at A union B is equal to B union A, here B union A, right? So next property of the union set, important property. Okay, property number 2, very simple. A union phi is equal to phi union A, which is A set. It means if you take any set of union set of phi set, A is a non-empty set and it is a null set. Okay, the union of non-empty set and phi set is also the set itself, A. Understand? The union of any set with the empty set is always the set itself. For example, let's the set A is equal to ABCD and A union phi what? Okay, which is same set A. And similarly phi union A union phi is equal to A set. Okay. Similarly, if you take phi union A, also A. Thus we get A union phi is equal to phi union A. Yes, which is the set A. This is also another fundamental properties, okay, of the union set. Thus union set, union of any set with the empty set is always the set itself, right? Now the property of union set, another property also you see, A union A is equal to A. It means the union of every set is the set itself, right? Yes. Another property is that, property 4, if A is a subset of B, then what will the A union be? Yes, A union B is equal to what? B. Yes. If A is a subset of B, then A union B is equal to B. This is another property. For example, suppose A is a set which is containing element ABC, and B is an element, B is a set, B is not element, B is a set whose element are here. Clearly you see A is a subset of B. Yes or no? Because all the elements of A are in set B. Thus A is a subset of B. Thus we find A union B, which is set. The A union B which set? The set B. Thus A union B, okay, is equal to B set. If A is a subset of B, the A union B is equal to set B. Clear? Understand? Okay, and very simply and very easily and lucidly, and you can understand this concept. And if A is a subset of another set B, then their union set is the superset, our set, superset. Yes. Yes. Another important property is associative property. As the binary operation, that is the associative law of addition, subtraction, multiplication, division. Similarly, in set union also, we have to explain the associative property by using example, by using property, by using Venn diagram. We can explain. And when three sets undergo union in any order, the resultant set always remains same. This is called associative property of set union. It means A union B, whole into A union B, whole into union C is equal to A union whole into B union C. This is the associative law. It means the associative property of union set. Okay, it means the union set follow associative property. Okay, right? So we have to prove it by giving example. How to prove example? Whole A union B union C is equal to A union whole B union C. Okay, understand? Right? Let's see here. Let's see, student, you have to a little bit, these are the very simple concept. Let's see. Okay, develop patience to watch this class. Let's see how to prove the associative property of union set. So taking example, let ABC are the any three sets. Here A is a set, element have been taken. Here these are the element of the set V. Here these are the element of the set C. We have to take the three sets, three non-empty set, right? We have to prove it. A union B whole into whole A union B union C is equal to A union whole B union C. For that, let LHS left hand side whole A union B union C. First of all, see, now the element of A written 1, 2, 3, 4, 5 union. The element of B are 4, 5, 6, 7, 8 and union. See, first of all you have to find out A union B, right? And A union B, what are the element? All the element of A and B, which is 1, 2, 3, 4, 5, 6, 7, 8 union C set elements, which are the 7, 8, 9, 10. First of all you have to find out A union B. After finding you shall get the resulting set, you have to find out union C. And these are the, you will get A union B union C. Look at here. Thus we get A union B whole A union B union C. Okay. Look at the element, what kind of elements are there. By taking all the elements of A union B union C, first of all you have to find out the unions of A and B. Then with the resulting set you have to find out union set C. Okay. Understand? Let's see RHS A union whole B union C. First of all you have to find out the union set of B and C, because B and C are under the bracket. So you have to use the bracket work first as per the rule. So here A union B union C, you see clearly also same element. So A union B, whole B union C also element, the same element they have. Okay, which is 1, 2, 3, 4, 5, 6, 7, 8, 7, 8, 9, 10. So these are the element has been repeated. If the elements are repeated and they are the same element, yes, understand? We can also write that set here. Understand? Yes. Here we can write. Okay, all the element you see, and hence we clearly understand LHS, RHS. Here the elements are repeated, and you know if the elements are repeated, they are considered as the same element, right? Here 1, 2, 3, 4, 5, yes, 6, 7, 8, 9, 10. This is element set. Okay, and this is the equation number 2 we got. The elements are repeated and they do not, the set do not vary. Okay, and it's clearly understood that both side, both LHS are equal to RHS. Thus it is also proved the whole A union B union C is equal to A union B union C. It means the union set obeys associative law. This is the we can prove it associative law property by using example. Also we can prove by using Venn diagram. Look at the Venn diagram here. Interesting Venn diagram for you. Look at the diagram here, and you see here the set A, here the set B is another set C taken. Understand? Okay, we have to see first element A union B. Look at here, the elements are written of this. Yes. So what are the element you have to write within the same Venn diagram? You see these are the element, these are region of the set A. The element are 1, 2, 3, 4, 5. Okay. So let us, you have to write down the element. Thus A union B, whole A union B union C. Look at here. This set you are taking. Yes. First you have to take A union B. A union B means all the element of A union B you have to take. The shading portion of A union B, all the element of A and B. Okay. Understand? So these are the element of what? A and B. Okay. Then after that you have to take the shading portion of union set C. Okay. Right. The entire shading portion, can you understand, is the element of A union B union C. Right. Understand? You can take all the same element also. You can take here. Also you can take this element also, you can be taken as the set. These also can be taken, all the set, right? Yes. So these are the shading portion of A union B union C, right? And finally we shall get the resultant set. You clearly understood the whole entire region of A, B, C, 3 sets, shading portion C. Yes. Okay, this is the whole A union B union C. Understand? Look at the interesting Venn diagram for you, right? Okay, and we shall get now RHS. Let's see what is RHS. Look at the diagram here, Venn diagram. You have to take first B union C, because B union C in the bracket. Okay, then you take the union of A. Understand? Yes. Okay, and final get and this side is A, this side is A. So entire shading portion of ABC finally is clearly understood that in both the cases LHS equal to RHS. right? Okay, understand? Yes. Okay, and from both the Venn diagram it is clearly understood that the set obey associative property under the union set. The set union obey associative law. Look at more clearly the Venn diagram can be understood. The associative property of union set. Okay. So please don't leave the class. Look at the class with patience. Very interesting and very easy class for you, which I am going to prepare with interesting Venn diagram for you, for your interest, for your understanding. Okay, and you clearly understand. There will no doubt for you. I hope it is my confidence to you. Okay, so you can clearly understand the concept of the associative property. How can we explain with the help of the Venn diagram, and thus the set union obey associative law. Okay, understand? Is it clear? Yes? Understand? Once again look at. Okay. Similarly, another we can prove it. See, how can we prove it? Using property also. See how the different methods we can use to prove the concept and property of set theory. This is very important. See, I have prepared for you in every concept and for your understanding. These are most different methodology which is most inevitable. You should know different methodology you can, what kind of different methodology can be used and in solving any mathematical problem process, and what are the different process methods we are using. That is the most important factor of the understanding about the math. Not only particular concept, what are the different, to explain a concept we have the different process, what are the methodology you are using. So it is, understand? So that you have to develop patience and also you have to develop interest toward the class. Okay, once you are the passion of mathematics, so it means you will imbibe, we will forget everything and also you will keep on practicing mathematics. Okay, so very important concept, interesting concept. We are going to prove the associative property using property method, and all of you know that if A is a subset of B and B is a subset of A, then A equal to B. Two sets are equal if A is a subset of B and B is a subset of A. Very simple concept in the first class. Okay, while discussing the property of the subset, in the same subset we can use to prove the associative property. Understand? If you can prove A union B whole union C is a subset of A union B whole B union C, and we can prove A union whole B union C is a subset of A union B whole A union B union C, then you can prove whole A union B union C is equal to whole A union B union C. It means using property method, these two conditions we have to verify. If these two conditions is verified, then we can prove it the associative law, the set union obey associative property, right? So let's see. Okay, how. First point we have to prove A union B union C is a subset of A union whole B union C. Let X belongs to whole A union B union C, right? It means X belongs to A union B whole A union B, or X belongs to C. It means X belongs to whole A union B or X belongs to C. Understand? And X belongs to A union B means already know according to builder methods, set property methods, X belongs to A or X belongs to B or X belongs to C. We can rearrange. If X belongs to A or X belongs to B or X belongs to C, we remove the bracket. Understand? Okay, again you see rearrange. After rearranging, X belongs to A or X belongs to B or X belongs to C. Here we have rearranged this one. This one has been rearranged. Understand or not? After rearranging, we will get, thus we get X belongs to A or X belongs to B union C. Understand? Yes? A union B union C what? Okay? Or X belongs to A or X belongs to B union C. It means X belongs to A union whole B union C. It means since X belongs to whole A union B union C, then X belongs to A union whole B union C. It means it is clearly proved that A union V whole A union V union C is a subset of A union whole V union C. Understand? Yes? Is it clear, this concept? Okay. And the point one, similarly you can prove it also. We can prove it on the A union B whole B union C is also subset of whole A union B union C. Okay. Similarly, let us take X belongs to A union whole B union C. It means X belongs to A or X belongs to B union C, right? Or X belongs to A or whole X belongs to B or X belongs to C. Because B union C means what? The B union C means, yes, here B union C means, okay, look at it, X belongs to B or X belongs to C. Okay, if you remove the bracket, you will get X belongs to A, this line you see, X belongs to A or X belongs to B or X belongs to C. Then you have to rearrange this one. This one you have to rearrange. After rearranging, you will get X belongs to A or X belongs to B or X belongs to C. Okay, it means X belongs to A union B. Okay, X belongs to A or X belongs to B, it means X belongs to A union B or X belongs to C. Thus we get X belongs to A whole A union B union C. Thus X belongs to A union whole B union C. Since X belongs to A union whole B union C, and also X is an element of whole A union B union C, and from the both the cases it is clearly understood that A union whole B union C is a subset of A union B union C. Okay, so from both the points, from equation 1 and 2, it is clearly understood that A union B whole A union B union C is a subset of A union whole B union C, right? And A union whole B union C is also subset of whole A union B union C. Thus, the union set obeys associative law from both the cases. This is the property methods using we can prove an important statement of the union set, that union set obeys associative property. Understand? So let's recapitulation of the property of union set. These are the important points of the union set. We'll discuss. Let us recapitulate. Okay. If two sets A and B are given, then union of A and B is equal to the sets contains all the elements present in A and in the set B. Second property already discussed. This operation can be represented as A union B is equal to X such that X belongs to A or X belongs to B, where X is present either in the set A and B or both the set A and B. And set union obey commutative property already discussed. We prove it by three methods: by taking example, by property, and by Venn diagrams. Okay, understand? Okay, the set union obey commutative law, and already discussed A union B is equal to B union A. It means, yes. And another property already discussed. Remember this, students. And the property union of any set with the empty set is always the set itself. A union phi is equal to phi union A is a set, and A union A is equal to a set. Every set, any set, the union of any set with itself is also the set, same set. Okay, if A is a subset of B, then A union B is equal to B. And union set obeys associative law. Already you prove it by three methods: example, by using property, and by Venn diagrams. Okay, and set union obey associative law. Whole A union B union C is equal to A union whole B union C. It is proved. Okay. Another important types of set, second set is intersection of set. So this is another operation of set. Understand? Then set union is the combination of set. Similarly, it has another meaning, intersection of sets. Intersection of set means, and we say it is also when two or more sets undergo the intersection, we shall get another set. Okay, understand? And intersection of set means of two given set, The intersection of two given set is the set that contains all the elements that are common. Those are common elements to both the set. It means those, suppose there are two sets A and B, so those elements are in the set A and in the set B only have to take that element, okay, in another set, and that resulting set will be the intersection of that set. Only common element you have to take. Remember the very common element. Once again see, those are the only common element. You take the common element. Those are present in both the set. Okay, understand? The symbolic representation of intersection set is intersection. This is the reverse of union. Okay. For any two sets A and B, the intersection of set A and B is denoted as A intersection B. Okay, we read as A intersection B. Okay. Thus, the intersection of set A and B is defined as the set composed of all that belongs to both A and B. Symbolically, the intersection of set can be represented as of the set A and B in the similar manner like the union set, but it is different is that the A intersection B is that X such that X belongs to A and X belongs to B. Here union set, in union set we are using OR, operator OR, but in intersection set we are using the operator AND. Here OR means in the union set what? Either the element is either in A or in B, but meaning of AND is that the element of A intersection B should be common element of both the set A and B. Only common element you have to take. Understand? Suppose X is an element of A intersection B, if and only if X is an element of both the set A and B. Very important concept. So you can use and the operator AND. Remember, for the intersection set you are using the operator AND to represent the intersection set. Those are the common element. Okay. We can use an example also. Let's say set A taken 1, 2, 3, 4, 5 and set B 3, 4, 6, 8, and here intersection set, look at here, both the set is 3, 4. Look at here, you see, and if you see here the set, what are the set present? Is 3 here, here 3 present, here 4 is the common element, here 4 is the common element. Yes, understand? Right? 4 is the common element, 3, 4, 3, 4. So 3, 4 is the common element that are present in the set A and B. So this is the resulting set intersection B. What are the common element of the set A and B? And this is the Venn diagram. The common area intersection portion of the two sets A and B. Okay. These are the element of 1, 2, 3, 4, 5. And here the 3, 4 is the element that are common to both the set A and B. Okay, write down the element of A and B. Then look at your common portion. What are the common portion? The common portion is what? 3 and 4. These are the common portion, 3 and 4. The element of the common portion. These are the common portion only. These elements are taken. Okay, understand? These are the common portion element. You have to take that are the element of the intersection set. Okay. It is more clearly you can understand here. A intersection B with another Venn diagram for you. Interesting Venn diagram for you. Look at the shaded portion is the portion that are common, okay, to both the set A and B. These are the common area, overlapping area. Understand? So I hope it is very simply and very you are able to understand the concept of intersection set with the help of the Venn diagram. Okay. Okay, understand? These are the common portion of A intersection B, shaded portion of A intersection B. With the help of Venn diagram, we are going to explain. Right? Similarly, intersection of three sets. The three sets are given. We can take the intersection of three sets. If ABC are the three sets, the intersection of three sets is the set of all elements that are common to both A, B and C. This can be represented as A intersection B intersection C. This can be better understood with the help of the example given below. Let us do an example. Here, taking A, B, C are three sets. The elements are here in front of you. Now the intersection of three sets is expressed as A intersection B intersection C. Yes, thus A intersection B intersection C is all the element, is the common element. Those are the common element to the set A, to the set B, and to the set C. Only you have to take. You see here what are the elements are here? D, E, F. You see S. S. Look at here. You see here. Here the D is present in the set A. Here also D. Here also D. Look at here. Here you have written D. Similarly, you see E is the present. The E is the common element of all the set, three set. Similarly, another element is F. Here F is an element of the set A, also the set B, and also the set C. So these are the common elements that are present in all the set, three sets A, B, C, but has been taken as A intersection B intersection C. This is the Venn diagram for you of three sets. Okay, look at here. Interesting diagram for you. Mathematical set theory operation also you can explain with the help of the Venn diagram. Okay, look at here. What are the common portion? Yes, D, E, F. Yes, look at here. You once again see these are the common portion. Yes, these are the common portion. Look at here. These are the common portion. These are the common portion. Indicate heading portion are the element of common to the set, three sets A, B, C. Understand? This is the shading portion. Yes. So you look at here the Venn diagram also, same Venn diagram. Yes. Okay. Are you looking? What are the common portion of the set A, B, and C? This common portion indicate the intersection of the set A, B, C, A, B, and C. Okay. I hope you are feeling boring. I understand, but while you are imbibing the concept, if you are a lover of mathematics, you must take interest and eagerness. You must have patience. As a math student and math learner, you must have developed patience. If you can develop patience in your work, okay, then if you really love your work, then you must take interest towards your work. Because mathematics subject, more and more problem you will solve, then more interest you will develop in you. That is the most important factor as a math student, lover of mathematics. Okay, you have a math lover first of all. So this is the common area of A intersection, B intersection. So clearly understand by this Venn diagram, right? Then again another property of intersection set. Likewise the property of union set, intersection set also we can discuss the property of intersection set. The intersections of any non-empty set with the empty set is always the empty set. It means A intersection phi is equal to phi intersection is always an all set. For example, you see the set 1, 2, 3, and if you take the intersection set of phi set, okay, it is a phi set. Similarly, phi intersection A is also phi set. Okay, because no element are common in both the set. Since there are no common elements, so you can take the resultant element, the intersection will be null set. If there are no common element, and you can say the disjoint set also. If the two sets having no common element, they are also called disjoint set. So A set and null set are both disjoint set because there is no common element in both the set. So their resulting set will be null set. Understand? Thus you get A intersection phi is equal to phi intersection A, which is equal to a null set. The another property we are discussing, idempotent law. Intersection of any non-empty set with the set itself is the same set. It means A intersection A is a set A itself. Yes, understand? Let us take A intersection A, okay, is A set, right? You'll understand. So A intersection A is equal to A set. Similarly, property 3, if A is a subset of B, then A intersection B what? Is A set A. In case of A union, it was what? Superset. But if A is a subset of B, then A subset of B, A intersection B is a set A. Okay. You take the element X, Y, Z, another set, you see beside B has been taken. It is clearly understood that A is a subset of B. And here, so A intersection B with Z, which is the set A. Okay. Look at with the example we are going to prove. Yes. Understand? Okay, let's proceed. Next property of the set intersection, property 4, that is the commutative property. Do you think the intersection set obey commutative law? Let's have a thoughts. Let's see. When the two non-empty sets undergo intersection in any order, the resultant set also remains same. It means the intersection sets obey commutative law, like set union. It means you have to prove A union A intersection B is equal to B intersection A. Understand? So set intersection obeys commutative law. Also you have to prove it. See, by taking example and by property and by Venn diagram. Consider two sets, the set A 1, 2, 3, 4, 5 and the set B 2, 3, 5, 6, 7. Now you have to say, let's see A intersection B, left hand side. Okay, the element are 2, 3, 5. Look at here. Yes. Understand? The element are 2, 3, 5. Here A intersection B. These are the common element. Similarly, if you take the B intersection A, also similarly element 2, 3, 5. Therefore, the A intersection B is equal to B intersection A. Okay, same element are there. Thus, set intersection obey commutative law. With the help of examples, we are going to prove. In the same manner, we can prove it by commutative law of intersection by property methods. Okay. Let's see how to prove the commutative law of the set intersections by property, by builder methods with the help of property. Okay. And we know that if A is a subset of B and B is a subset of A, then A is equal to B. Same thing I am repeating. While discussing the property of subset, this is important. Two sets are equal if both are subset to each other. If A is a subset of B and B is a subset of A. Similarly, if you can prove A intersection B is a subset of B intersection A and B intersection A is a subset of A intersection B, both terms. Understand? Then it can be proved that the set intersection obey commutative law and the commutative law intersection can be proved by taking this concept, the property of subset. Okay? Let's see here. Let X belongs to A union A intersection B. If X belongs to A intersection B, then what happens you see? X belongs to A and X belongs to B. Right? We have to use the operator AND while studying the intersection of set A and B. If X belongs to A and X belongs to B, it means X is the common element of A and B. It means if X is present in B, it means we can also X is present in also A and X is present in B. X belongs to A and X belongs to B. It means that the element are both common in A and the set B. Or we can write also the X belongs to B and X belongs to A. Yes or no? Because that element also present in B. It means X belongs to what? B intersection A. Understand? Yes? Okay? Clear? Thus, it is clear since X belongs to A intersection B and X belongs to B intersection A. Okay, thus A intersection B is a subset of B intersection A. Similarly, suppose the X belongs to B intersection A. If X belongs to, it means if X belongs to B, then X belongs to A. And X belongs to A and B. And X is the common element of both set A and B, right? It means X belongs to A intersection B. Very simple concept. Since X belongs to B intersection A, then X belongs to A intersection B. It means B intersection A is a subset of A intersection B. Okay, understand? Clear? So similarly, and both the cases we understood that A intersection B is a subset of B intersection A, and B intersection A is a subset of A intersection B. Thus, the set intersection of a commutative law by property methods. Okay, and we prove it. And also, while you are proving this property, if the questions are coming, mostly used to come, and you have to, by property methods, you have to do by property methods. If it is giving by examples, you have to do by examples. So that's why you have to study the various methods. Also, you have to do the Venn diagram method also. How to prove by Venn diagram methods? Also, you have to prove. Okay, you can prove it. Another important property of that is the distributive property, distributive law. Understand? What is distributive law? See? Okay, this is another vital theorem and statement. It is a combination of the union set and the intersection set. If ABC are three any non-negative set, A union whole into B intersection C is equal to A union B intersection A union C. This is called the distributive law of union over intersection. This is the distributive law of union over intersection. Okay, this is the property 1, very important property, vital property. Mostly used come in your CBSE paper and also vital different kind of exam. This property you have to verify. Similar, another property is that second one, the A intersection whole into B union C is equal to A intersection B union A intersection C. It means the distributive law, this is called distributive law of intersection over what? Union, right? Okay. Let's see. If A, B, C, B, 3, any 3 sets. Okay. The first set, let me see, prove how what is the distributive law of union over intersection. This is the distributive law over distributive law of what? This is the distributive law of union over intersection. Understand? So before the bracket you see there is the union set here. You see, and this is the inside the bracket is the intersection. This is called distributive law of union over intersection, and which is equal to A union B intersection A union C. Right? Here union set is undergoes distribution. Understand or not? Yes. Let's see it. To prove it, A union whole into B intersection C is equal to A union B intersection A union C, and we can prove it using property methods. Since if A union B intersection C is a subset of A union B intersection A union C, you can prove it. Let X belongs to X is an element of A union B union C. Right? Understand? It means X belongs to A union whole B intersection C. It means if you carefully see, if X belongs to A union means R, or X belongs to B intersection C, this is one of the set. Okay. Understand? So X belongs to A or X belongs to B intersection C, and X belongs to A or X belongs to B intersection C. If you see X belongs to A, here X belongs to B intersection means you have to use the operator hand. For the intersection set you have to use the operator hand, yes or no? So X belongs to B and X belongs to C. Okay. So if you rearrange, if you remove the bracket, so you see, look at here, interesting thing. Here X belongs to A or X belongs to B. This OR will be distributed. Here use AND means here you AND here, and X belongs to A or X belongs to C. This OR will be distributed to C. Understand or not? Yes. Okay. Thus X belongs to A or X belongs to B, and X belongs to A or X belongs to C. And you see, again you can give the bracket work here. X belongs to A or X belongs to B, and X belongs to A or X belongs to C. Just the rearrangement using the bracket rule, and you can see clearly this is the X belongs to A union B and X belongs to A union C. Right? Understand? It means X belongs to A union B intersection A union C. Okay? And it clearly understood X belongs to A union B intersection A union C. Similarly, it can be proved that, okay, it is prove A union pole V intersection C is subset of A union V is intersection pole into A union C. Similarly, it can be proved that A union V intersection A union C is also a subset of A union hole into V intersection C. Okay, how to prove? It is also proved. See, it is every detail I am going to explain for you. As let X is an element of A union V intersection A union C. It means X belongs to what? X belongs to A union V intersection A union C. Okay. Then you say X belongs to A union V. Here you see and you are using operator and means here you have to use what? And operator for intersection. So X belongs to what? Here you see X belongs to A union B and X belongs to what? A union C. Right? Achha. You see now X belongs to A union B means what? X belongs to A or X belongs to B. Similarly, X belongs to A union C means X belongs to A or X belongs to C. Union means or operator we use. Right? For the union set, what is the operator or? For intersection set, use the operator AND. Now you see the bracket where you see clearly, look at here. Here you see X belongs to A or X. This operator can be taken as common. Can you take common here? Here X belongs to A or X belongs to A can be taken as common. Here common has been taken. So after taking the common, you have taken the bracket, square bracket. Here X belongs to B. Here AND is used here. Look at here. Here AND is used and here X belongs to C. Understand? So thus we get X belongs to A or achha, here means what? X belongs to B and X belongs to C means X belongs to B intersection C. Okay. Thus we get X belongs to A union. Thus X belongs to A union hole into X belongs to B intersection C, and it's clearly understood that A union V intersection A union C is a subset of A union hole into V intersection C. So in both the cases you clearly see. Okay, understand? So both cases we see the set intersection. This is the distributive property of union set over intersection, which has been proved using property methods. Okay, very important concept. Already in the class 11 you know this, and you have to also remember it, practice it. Okay, understand? This is the distributive law of union over intersection. It is proved using by property methods. You can take also example also. You can prove it. Similarly, if A, B, C be three sets, and this is the distributive law of intersection over union. This is the distributive law of what? Intersection. This is the intersection which is before the bracket and inside the bracket union. So that's why distributive law of intersection over union. Is it clear? So there are two distributive property. One is the distributive law of union over intersection, and this is the second part. Second point, distributive law of intersection over union. Both points sometimes mostly used to come in your exam. Okay, and also various statement you have to prove using this property. Set theory, various property and statement you can use with the help of this property. Let us prove it similar manner using property methods. How to prove? You see here, we have to prove it first. A intersection V union C is a subset of A union intersection B and union A intersection C. Let X be an element of A intersection B union C. Then you see the X belongs to A intersection B union C, right? Or you can write X belongs to A or X belongs to B union C, right? X belongs to A and this is the operator and here before the bracket, so you have to use and operator here. Okay, and X belongs to A and here you see X belongs to B union C. B union C means what? X belongs to B or X belongs to C, right? You see the X belongs to A and you see X belongs to A and if you remove the bracket, so X belongs to A and X belongs to B. Here using or, you have to use or here. Here X, this is the X belongs to A and also multiplied here X belongs to A and X belongs to C. It will be undergoes distribution. This is called distribution. Okay, here X belongs to A and it will be distributed because this is before the bracket work. While you are using the bracket work, this point please note down and remember also. Okay, so understand? So if you rearrange, now you see if you rearrange x belongs to A and x belongs to B, x belongs to A and x belongs to B, or you give the bracket, here x belongs to A and x belongs to C, here x belongs to A and x belongs to, then let us use the bracket word, and you see x belongs to A and x belongs to B. What is the value? X belongs to A intersection B. Similarly, x belongs to A and x belongs to C is also x belongs to A intersection C. Understand? Clear? Okay. Thus we get x belongs to A intersection B union A intersection C. So since A intersection B union x belongs to A intersection B union C, then x belongs to A intersection B and union A intersection C. So it is clearly understood that, okay, what is understood? So since x belongs to A intersection B union A intersection C, okay, thus it is a subset. A intersection B is A intersection whole B union C is a subset of A intersection B union whole into A intersection C. And similarly, can we prove that? And the reverse part also we can prove it. Okay, A intersection B union whole into A intersection C is also a subset of A intersection B union C. Okay, similarly, see, it has been also proved it for you. Similar manner, let x be an element of A intersection B union A intersection C. Right? Okay, it means x belongs to A intersection B union A intersection C. It means x belongs to A intersection B here, or your operation is union set, so it's or operator you can use, x belongs to A intersection C. Okay, understand? So x belongs to A intersection B means x belongs to A and x belongs to B, or x belongs to A and x belongs to C. From this point you will get this one. Okay, builder methods. Now you see x belongs to A and, see x belongs to A and here, x belongs to A and here. You can take the here common. After taking the common, here what left? Here x belongs to B, x belongs to B. Here or operator is, here or operator you have to use. Understand? Here x belongs to C, x belongs to C you have to use. Here, thus we get this statement, this line. It means x belongs to A and x belongs to B union C. Here, this is the B union C, right? Understand? So x belongs to A intersection x belongs to B union C. Okay? Thus we get A intersection whole B union C is a subset of A intersection B union A intersection C. In both cases we got. Okay, this is how we have to prove. We prove it. Distributive law of intersection over union. This is the distributive law of intersection over union. Intersection over union. Understand or not? Yes. Okay. So very important statement. Once again you watch again and again and also practice. Okay. Here Venn diagram also you see. It has been so okay. Here Venn diagram, how can you prove the distributive law of union over intersection? Yes. If A, B, C, B, any three sets, then A union B whole B union C is equal to A union B intersection A union C. Distributive law of union over intersection. Look at here the Venn diagram. Here ABC, you have to take the three sets. Yes, first B intersection C. First you take the element of B intersection C because the common element. Okay. Then you have to take their union set, A set you see. Interesting diagram. Look at the shading portion carefully. These are the A union B, A union whole into B intersection C, and finally we got what are the region you see, common region. shaded portion of the set A, B, C distributive law of union over intersection. Look at the shading portion. Finally we got, carefully see, very interesting diagram, clearly understood, can be proved with the help of the Venn diagram. Right? You see the shading portion, is it understood or not? And same, both shading portion are equal. You see, both the portion are equal. Yes? Understood? Okay. Similarly, we have to the another part, RHS right hand side, which is A union B intersection A union C. Look at the set, three sets. Yes, ABC. First of all, you take A union B. Look at here. Similarly, take the A union C. Shading portion A union C. Okay. Look at here. First you have to take A union B, then A union C. And finally you will got the shading portion here with the help of Venn diagram. Okay. Exactly the same cross sectional area. What are the portion we are taking? Yes. So these are the portion, common portion of A union B intersection C is equal to A union B intersection A union C. This is the distributive law of union over intersection is proved using the Venn diagram. Look at the shading portion area. Yes, both are C. Okay. So difference, another important property, that is the difference. So first we study on the important operation, that is the union set. Second part is the intersection set. Another part is the difference set, difference of two sets, the another set operation. Likewise, the addition, subtraction, multiplication, division in algebraic operation. Similarly, there is important set in set theory also. The difference of two sets is also another important concept. Okay, how to take the difference of two sets? The difference of two sets A and B is all of those elements of the set A which do not belong to the set B. Symbolically we write A difference B, read as A minus B, or we say A difference B. In cell builder methods, we can write A difference B is equal to X such that X belongs to A and X does not belongs to B. It means those elements are in A but not in B. We have to take the element, we have to make the set, that set is known as A difference B. Okay? Understand? So in the set builder methods, we can write it as A difference B is equal to X such that X belongs to A and X belongs to X does not belongs to B. Similarly, B difference A, in those elements are B but not in A. Okay, which in the builder methods we can write B difference A is equal to X such that X belongs to B and X does not belongs to A. For example, we can take if A is a set A, B, C, D, B is another set D, E, F, G, H, G, then A difference B. What are the element of A difference B? You see, A difference B means those elements are in A but not in B. You see, clearly you see the element A is element in the A but not in the set B. Second set, or B in the first set but is not in the element of second set. C is the element of first set but C is not the element in second set. So this element can be taken, which is A difference B. The element is A, B, C. Understand? Okay. Similarly, B difference A. B difference A means those elements are in B but not in A. So which is E, F, G. These are the elements. Okay. And the Venn diagram also you can take. Interesting Venn diagram. Very vital, important Venn diagram. Mostly is required to understand clearly the concept of the set theory. Venn diagram plays a vital role in understanding the set operation and types of sets. See here, these are the elements of the Venn diagram. We are taking the set. So what are the element of A difference B? A minus B, A difference B. The shading portion you can understand clearly. These are the difference. These are the area to indicate the difference of the set A and B. A minus B. Okay. This is A minus B. Similarly, B difference A. Look at here. Let us write the element of the set A and B first of all. And you see the shading portion which is E, F, G. Understand? Clearly see the Venn diagram also with the example. Okay, you see EFG, the element of A difference B, yes, is the element of B difference A, this is the element setting portion, understand or not? Yes. Okay, once again see carefully. Okay, let's move. Difference of two sets we are discussing with the example. Let's see one example. Suppose an element A is taken. A is a set, non-empty set. B is another non-empty set. Then A difference B, the element are 1, 2, 3 with the help of Venn diagram. You see, these are the element of A, difference B. Clearly understand? Yes. Okay. Okay. Similarly, B difference and A difference B. Once again see the Venn diagram here. This is the Venn diagram shaded portion which indicates A difference B, and these are the area only in the set A. And this area will not intersect the portion B. Okay. This is A difference B. Understand? Similarly, B difference A, the set A and B, right? Here the area shaded portion. The shading portion indicate that the element are only in B, not in A, which is B difference A. Understand? Right? This is very amazing Venn diagram, interesting Venn diagram. Okay. I hope you might taking interest and eagerness toward the class. These are the concept of A difference B and B difference A using the Venn diagram, right? Another difference of set example, look at here. Here I mean so many example I am describing, explaining very vividly and lucidly for you, only for you. Okay. So find A minus B and B minus A. So this is A minus B. The element are in A, not B. Similarly, B difference A. The element are in B, not in A. You clearly understand that the element in the A difference B element, which kind of element? 1, 2, B difference 7, 8. And once again see clearly the A difference B is not equal to B difference. It means the difference set does not obey commutative law. Set union and set intersection obey commutative law, but the set difference does not obey commutative law. Okay. Another example, here I am going to explain difference of three sets. Here you see this element x, y, z. These are the set x, y, z. Three non-empty set. You have to find out x difference, y difference, z. X difference, y difference, z. Second point, y difference, x difference, z. So x difference, y difference, z means those elements are not in y and z. We can take. And y difference, x difference, z means those elements are in y but are not in x and z. Clearly you see. Last point, x minus y minus z. These are the element 1, 2, 3, 5, and these elements are only in A but not in y and not in z. Similarly, y minus x minus z, y difference x difference z, those elements are only in y but not in x and z, which is 6. The 6 the only element in y but not in only element in y but not in x and z. Clearly understood or not? It means you see x minus y minus z is not equal to y minus x minus z. It means the set difference does not obey associative law. Okay. These also indicate another property, that the difference of three sets do not obey associative law. It means the set difference does not obey associative property, right? Okay. Understood? Okay, thank you. Let's see. X minus y minus z is not equal to y minus x minus z. Look at the diagram, Venn diagram also, it has been explained. Yes. Okay. This is the shading portion of x minus y minus z. These are the only area covering x. Okay, only the part of x. Those are not in the part of y and z, it does not cover. Understand or not? These are the area covering only some portion of the only portion of x. Okay, but some portion of x also in y and z and does not cover. See here also, y minus x minus z, right? See this portion, only the portion y area it's covering, but some portion of y also in portion of x and z which has been overlapped, and this overlapping area of y and z is, of y in x and z is not covering. Understand or not? So clearly you see, clearly understood? Yes. Follow and practice also. Okay. And in both cases it is clearly understood that the difference set does not obey associative law. Important properties of set difference also. Likewise, the unions and intersection set, we can write also some of the properties of the set difference. See here property 1. If two sets A and B are identical, then A difference B equal to B difference A is a null set, which is an empty set. And A difference A, identical means A equal to B. If two sets are equal, A and B two sets are equal, then their difference set always null set. A difference A is null set. B difference B is also null set. Similarly, difference between non-empty set and an empty set is also the set itself. A minus phi is equal to A. Okay. Another property, property 3. If we subtract the given set from itself, we get the empty set. Mathematically, A minus A is also null set, just according to property number 1. Okay. Every set, the difference of any set of itself is always null set. This is another property. The difference of set of a non-empty set from an empty set result in an empty set. Phi minus A is also phi set. Okay. So you can check it, you can prove it by taking examples. But remember, you have to use it while you are proving the different operation and set theory and proving the different statement of set theory. Similarly, to above property, the difference of set of universal set from any other set is again equal to the empty set. A difference is also null set. Okay. Property 6. If you subtract a superset from a subset, then the resultant set is also null set. It means A difference B is equal to phi if A is a subset of B. And property 7. If A and B are two disjoint sets, they do not hold any common element, then A difference B is equal to A and B difference A is equal to B. Okay. This states that A difference B is equal to P if A intersection B is equal to phi set. Right? If A and B are no common element, then A difference B is equal to P. It means A difference B means all the elements, those elements are in A. You can say P means which? All the element of the set A. This is not P, this is, you can take A also. A difference B is equal to what? A set, right? This is the A set. Understand or not? Similarly, B difference A is equal to B if A intersection B is also phi. Right? Once again, property 8. So many properties we are discussing over the difference of two sets. If A and B are two non-empty sets, the total number of elements only in the set A is only in the set A. It means no. This is the number of element of A difference B, the cardinal of A difference B. Who is the cardinal of A difference? The cardinal of A intersection B. Very important concept. A difference B, the element only present in only in the set A. So A difference B means only A. Okay. Clearly understood also. Only A means what? Number of element in the set A difference B. What are the element? Only A difference B. These are the element present in A difference B, setting portion. Right? Okay. This is the intersection A. So another property 9. So many properties are discussing over the different set. If A and B are two non-empty sets, the total number of element only in the set B. Similarly, the number of element only B means the total number of element B minus A, it means magnitude of B minus A It means the cardinality of B minus cardinality of A intersection B. Number of element of B minus number of element of A intersection B. Here is the Venn diagram for you to understand this clearly. Okay. What is the meaning of only B means? The element of B minus A. So B minus A means only B, and A difference B means only A. These are the area shading portion indicate the element in A, B minus A, B minus A, it means only the element of only element B. Those area are not covering the portion A. This is the area. This is called B minus A. So B minus A means only B. The number of element in B. These are the element, number of element in B. How many element? How you have to calculate. So only B means, okay, the cardinality of A difference A, okay, which is cardinality of B minus cardinality of A intersection B, right? Another important property, that is symmetric difference of two sets. Very important concept, symmetric difference of two sets. Alright, the symmetric difference between both the set A and B is the set that contains the element that are present in both the set except the common element. The symmetric difference between the two sets is also called the disjunctive union. It means, the word disjunctive means the absence of connection. Absence of connection means those elements only present in A difference B and B difference A. Suppose A and B are the two sets, we have take the difference set, all the element of A difference B and B difference A, we have to take, that is the element of absence of connection. Those are not overlapping area. Symmetric difference can be defined the set of all the elements contained in the set A minus their common element. What are the common element? Set of all the elements of both the set minus common element. We have difference minus element. The symmetric difference of two sets A and B is denoted by the symbol A delta B. Understand? And A delta B, those elements only present in A difference B and B difference A. We have to take, let us see, we can write the A delta B, which is the symmetric difference of A and B, set A and B, which is A difference B union B difference A. It means all the element of A difference B and B difference A can be taken as another set, that is known as A delta B. Understand? Or you can write A union B, all the element, you have to take minus their common element, A intersection B. You have to take symmetric difference, A delta B is the symmetric difference, means all the element minus, you have to take the set, by taking all the element, you have to take minus their common element. What are the common element? You have to minus, you have to deduct. Understand? All the element except their common element is called A delta B. Clearly understood or not? Right? Okay. So here is an example here. Look at the example. A difference B is 1, 2, B difference is, so A delta B is A difference B union B difference A, which is, okay, 1, 2, 5, 6, 7. Thus A delta B is equal to, similarly you can take also A delta B, A union B difference A intersection B, and you can get the same element here. Look at here, same element. Okay, so these two formula are symmetric formula, equivalent statement, and to find the symmetric difference of the two set A and B, which is read as A delta B. This formula is, one formula is A difference B, so A delta B is equal to A difference B union B difference A. Another formula A union B difference A intersection B. Remember this formula. Understand? Okay. Look at the Venn diagram also. Yes. Here the element of, got A delta B, A difference B and B difference A. Okay. The elements are A difference B. This is the element of A difference B. Yes. Understand? Arrow mark clearly indicate that. Okay. Then you see the shading portion of A difference B and B difference A. By taking the element of A difference B and B difference A, we can find out the symmetric difference of the two sets A and B, clearly, which is clearly understood with the help of the Venn diagram. Right? These are the area indicate the symmetric difference of the two sets by taking the difference of A difference B and B difference A. By taking all the element of A difference B and B difference A. Okay? Understand? Okay, clear? Shall we move next? Again you see A difference A delta B, you understood A difference B union B difference A, and A delta B is equal to A union B difference A intercept. These are the two formula. Note down here. Okay, more clearly understood by Venn diagram. Right. A difference B and B difference A, those are the element present in A difference B and B difference A. So vividly I am going to explain for you only, for your understanding over the concept of set theory, which is very illicit and very easy chapter for you. Without any hesitation you can practice it, right? Understand? Okay, is it clear? So once again see, understand, this is the property of, this is the Venn diagram of symmetric difference of the set A and B, A delta B. Okay, and here is property of the symmetric difference. So these are the property are most useful. And property 1, that commutative property of symmetric difference. Do you think the, see, different set does not obey commutative law, but do you think the commutative law, symmetric difference obey commutative law? Very interesting concept. Let's see how. A delta B is equal to B delta A. It means the symmetric difference set obey commutative property, right? For example, we have taken the two sets A and B. You see, now find out A delta B, which is A difference B union B difference A. So A delta B is A difference B is 6. Next you find out B difference A, which is the element 9 and 2, and we taking the element of A difference B and B difference A, we shall get 6, 9, 2. This is the element of A delta B. Understand? Okay. Once again see. Yes. This is A delta B. Understand? This is A delta B. This is A delta B. Okay. Understand? Yes. Similarly, to the right hand side, B delta A, it means B difference A union A difference B. Okay, the B difference A is the element 9, 2 and A difference B 6. Take the element B difference and A difference B, also A delta B. So both the cases it clearly understood that this is the B delta A. Right. B delta A. B delta. Understand? And from both the cases it clearly understood A delta difference B union B difference A. The element are same, B difference A union A difference B. In the same cases, both the cases, and it is clearly understood. A delta B is equal to B delta A. Thus, you prove that the symmetric difference set of two sets obey commutative law. Yes? Understand? Is it clear? Okay, fine. And let's see another property. Associative property of symmetric difference. Do you think the symmetric difference set obey associative property? Yes. Another interesting concept. Look at here. The associative property of symmetric difference. Right? Let's see. It means the symmetric difference set obey associative law. A delta B whole into A delta B delta C is equal to A delta whole into B delta C. Very interesting concept. Okay. It obeys commutative law as well as also associative property, but different set does not obey. Okay. We already prove it. See here A delta B delta C. With the example you have taken, let us here A, B, C are the three non-empty set. We have taken some element in the set A, B, C. A, B, C are three non-empty set. First of all, we will find out A delta B, which is A union B minus A union C. And the element are, what are the element of A delta B? 1, 4, 5. Thus, A delta B is equal to 1, 4, 5. Let's the element M. Suppose this is another set M. Now you have to find out A delta B delta C, which is A delta B means M delta C. Okay. Now you find out M delta C, which is M union C, difference M intersection C as per the formula. In the set M already we got 1, 4, 5. The set C is given. Again you find out M union C, which is the element of all the element of M and C. 1, 4, 5, 6, 7, 8, right? M intersection C is the common element, which is the element 4 and 5. 4, 5 common element you see. Yes, common element here. 4, 5, 4, 5 here. So you can find out, okay, M delta C, which is M union C difference M intersection C. Okay, and you will get the element 1, 6, 7, 8. Thus we get whole into A delta B delta C is equal to 1, 6, 7, 8. Okay, understand? Similarly, right hand side RHS A delta B, A delta whole into B delta C. Okay, you see, first you find out B delta C, bracket work, which is B union C difference B intersection C, and B union C is equal to 2, 3, 4, 5, 6, 7, 8. The element are B intersection C 4, 5. So B delta C is equal to B union C minus B intersection C, and we shall get the element. What are the element of that? 2, 3. Okay, these are the element. B delta C, let the another set we are getting, that is the, let the set N. Okay, then you have to find out A delta B whole into B delta C, A delta whole into B delta C, or A delta N, because B delta C is N already. So which is A union N minus A intersection N. First of all you find out A union N, which is, okay, and you see, after that you are getting 1, 6, 7, 8. Thus you get the RHS A delta whole into B delta C, which is 1, 6, 7, 8, and both the cases we got. Okay, it is verified that both the A delta B delta C, it means the symmetric different set obeys associative property, right? Okay, another property, important property you see. Look at again the previous page you see here. Okay, understand? Once again see here, right? See here, property 3 is, if A is a subset of B, then A delta B is equal to B difference A. Interesting property. If A is a subset of B, then A delta B is equal to B delta A. A is a subset of B means what? A delta B is equal to B difference A. Let A, the set A, the element having A, B, C, D. Here B is a set having element A, B, C, D, E, F. Then A union B is equal to A, B, C, D, E, F, which is B, because A is a subset of B means A union B is equal to B. Similarly, A intersection B is what? A, B, C, D, which are the common element, which is A, because A, if A is a subset of B, the intersection set is a subset, and the union set is the superset. Then similarly, we will get, know that A delta B is equal to A union B difference A intersection C, and here A union B is B set. B set. Look at here, A union B means B set. B set, and intersection B is vertex set, so it is B minus A, right? So A delta B is equal to B difference A, which is true. So property 4. Another property is that A delta null set is a set itself, is the same set. Suppose A delta phi is equal to A set, because phi is a subset of every set, phi is a subset of A. So A phi, A difference phi is A set, and phi difference is phi set. So A delta phi is equal to A difference phi union phi difference A, okay, which is A difference phi, and A difference phi is A set. Thus A delta phi is equal to A set. Very interesting concept, right? Okay. So thank you all of your patience and interest and eagerness for showing the class. Okay. Please wait, because I am going to prove any vital interesting statement here and properties here, and it is mostly essential for you, and you must read and take interest toward the class yet. So I hope you will watch the class till the end. So another property is A delta A is equal to null set, right? Here A delta is null set, because A is a subset of A, so A difference A is null set. Okay. Here another property, very important property from another set, that is known as the complementary set, which is the use of the different set. Okay. And what is complement of set here? Let's see. Complement of set definition is that if U is an inversal set and AB any subset of the set U, then the components of A is in the set of all the members of the universal set U which are not the element of A. Alternatively, it can be said that the difference of the universal set and the subset A gives the complement of set A. The complement of set A, which is represented as A dash, right? Mathematically, we can write the complement of set A is written as, so A dash is equal to U difference A, and complement set is the difference of the universal set and the given set is known as complement of set. Is it clear, the definition? Understand? What are the elements are in the universal set but not in the given set? We have to take such kind of element in the another set, that is known as the complement of set. So that is known as A dash. The complement of set A is known as A dash, which is U difference A, the difference of the universal set and the given set. And in the elder methods we can write X belongs to U, but X does not belongs to A. This element does not belongs to A. Those elements only U but not in A. So this is another use of difference set. The complement set is nothing in the difference of the universal set and a given set is known as the complement of set, right? Understand? So here is an example of the complement of set. Look at here. Let the universal set given. These are the universal, one universal I have taken, some element I have taken. Here A is a subset of universal set U. So the complement of the set A dash is equal to U minus A, with the element are in U but not in A. So these are the element which is 4, 5, 6, 7. Okay, and which is known as A dash. Complement of the set A is known A dash. The elements are 4, 5, 6, 7. And these elements are the element of the universal set but not in the set A, right? Understand? So this is a simple example and with a give a clear understanding about the complement of given set and with the relationship between the universal set and given set by the difference, by the minus, by the difference set operator. So difference set, complement of set is the difference set of the universal set and a given set. See, those elements 1, 2, 3 are in U but also 1, 2, 3 are in U. Mean these elements you have to deduct. But these elements are in U also in the set A. That's why you have to eliminate these are the element. By taking the element, we have to take the find the complement of the set A, which are the elements 4, 5, 6, 7. Understand? So Venn diagram you see. Suppose A dash is U difference A. Look at here. This is the set A and this is the universal set. These are the shading portion. This area do not touch the oval region of A. Okay, right? So many interesting concepts I am going to discuss here. Again, I will do after this the properties of complement of set and also De Morgan's law, very important vital statement in the set theory, and also some important theorem, and I am going to prove with the help of the examples and Venn diagram. So these are the element of the complement of set. Okay. Once again see, understand, this is the complement of the set A. Okay, understand? Look, let us proceed to the next property of complement of set here. Let's see here, first property. If A is a subset of a universal set, then A dash is also a subset of a universal set. Therefore, the union of set and its complement of set is a universal set. Understand? It means A union A dash is equal to U. So here A union A dash is equal to U. Okay? Similarly, the property 2, A intersection A dash is a null set. Okay, and here another property, A intersection A dash is a null set, right? For example, here the universal set, you have taken another set A and here A dash is equal to U minus A. The element are 1, 2, 3. Now you have to notice that A union A dash is equal to universal set, yes or no, right? Here this element U set 1, 2, 3, 4, 5 and A set A dash set 1, 2, 3. If we take all the elements, we shall get the universal set, right? Which is, thus we get A intersection A dash, and A union A dash is equal to, similarly A intersection A dash is null set, yes, right? A union A dash is equal to universal set. Then A dash A intersection A dash is what? Null set. Also important property. Property of the complement. Laws of double complementation. Let's see. The complement of the complemented set is the original set. In A dash whole dash is equal to A. The complement of complementary set is the set original set. Let here is universal set where the element are 1, 2, 3, 4, 5 and the set A containing the element 4, 5. First of all we find out the complement of the set A dash is equal to 1, 2, 3. Again A dash whole dash which is A minus U minus A dash which is 4, 5 which is equal to the set A. Clearly understand or not? See here. His element are same. Understand? So U difference A dash whole dash is equal to what? The set A. Thus we got A dash whole dash by property methodology has been proved using property methods. Okay, let X belongs to A dash whole dash. It means X belongs to U difference A. It means X belongs to U and X does not belong to A dash. And X belongs to U and X does not belong to A dash. And X belongs to U and X belongs to A. Understand? It means X belongs to A. Thus we get the A dash whole dash is A. Thus the complement of the complement of set is the set given set. Similarly, U dash is equal to 5. It means the complement of a universal set is equal to 5 because U dash is equal to U minus C. Thus naturally it will be 5, right? Understand? Okay. Another property, phi dash is equal to universal set. Phi dash. Another important concept I am going to discuss, the De Morgan's law, very important concept, and it is the use of complement of set of the union set and intersection set. The property of the complementary sets using the set union and set intersections, okay, and mathematician De Morgan's formulated important statement that is known as the, according to him, it is known as De Morgan's law, and in this, okay, and I am going to explain, this is one of the important vital statement formulated by him using the concept of union set and intersection set. So according to him it is popularly known as De Morgan's law. Okay, and here we are going to prove it by using the example, property and the Venn diagram. Very interesting and important and vital concept. Okay, let's see and look at carefully this statement. First of all, De Morgan's first law, which is A union B whole dash is equal to A dash intersection B dash. De Morgan's second law, which is A intersection B whole dash is equal to A dash union B dash. So let's see first De Morgan's first law. Okay, what is which is A union B whole dash is equal to A dash intersection B dash. Let's see first law of De Morgan's. Right? How to prove this one? We can prove it by using property methods. Okay, because if A union B whole dash is subset of A dash intersection B dash and A dash intersection B dash is also subset of A union B whole dash, then we can prove it. The De Morgan's law can be satisfied, can be proved. Let X belongs to A union B whole dash. If X belongs to A union B whole dash, it means the complement of A union B. It means X does not belongs to A union B according to the definition of complementary sets. Those elements are A union B whole dash. It means they are not in A union B. Since X does not belongs to A union B, it means X does not belongs to A and X does not belongs to B. And if X does not belongs to A, then X belongs to A dash and X belongs to what? B dash. It means X belongs to A dash intersection B dash. Thus we get A union B whole dash is a subset of A dash intersection B dash. Similarly, it can be proved that A dash intersection B dash is also a subset of A dash intersection B dash is a subset of what? A union B whole dash. Okay. A dash intersection B dash, this statement, once again rewrite this. This is the A union B whole dash. A union B whole dash. Once again rewrite this. Okay. We can prove it. Understand? Yes. And in both the cases we can prove it. The A union B whole dash is equal to A dash intersection B dash. Okay. The alternative methods of De Morgan's first law, which is A union B whole dash is equal to A dash intersection B dash. Okay. Let A union B whole dash. Give an example. By taking example, you can prove it. Let A and B are the two non-empty sets. First of all, you find out the universal set. Let us take the universal set. You have to take, then you find the A union B. This is the A union B. Okay. And the A union B set. And then you find out A union B whole dash, which is E difference A union B. The element of A union B whole dash. Okay, look at here. 10, 11, 12. Thus, A union B whole dash is equal to 10, 11, 12. Using the concept of different set. Similarly, RHS right hand side A dash intersection B dash, and A dash means E difference A, which is a difference of universal set and the non-set, which is find out E difference A, then you find out A dash is equal to 6, 7, 8, 9, 10, 11, 12. So B dash is equal to E difference B, find out B dash, which is E difference B, which is 1, 2, 3, 10, 11, 12. Then you find out, so this is the A dash, complement of B dash, again you find out A dash intersection B dash. And what are the element? After taking A dash intersection B dash, which is 10, 11, 12. Same elements. Thus A dash intersection B dash also 10, 11, 12. Same elements it contains. Since A union B whole dash is equal to 10, 11, 12. So both the cases it is clearly understood that the A union B whole dash is equal to A dash intersection B dash with the help of example. And it is clearly understood. We can prove it. De Morgan's law using the property methods, also by the example, and also you can prove it by the Venn diagram. Okay. De Morgan's first law using Venn diagram also you can prove. All the cases is very much required, essential to justify the statement, verify the statement of the De Morgan's first law. Here you see here. Okay, here A union B. First of all, you take A union B. All the elements set of element of A and B. These are the setting portion of A union B, right? Understand? And then you find out A union B whole dash. Those element, these are the set A and set B, and these are the element area A union B whole dash, because this area will not include the set A and B region. Okay. This is the A union B whole dash, right? Okay, this is the A union B set, this is the A union B whole dash, complement of A union B. See, again you find out A dash intersection B dash. First of all, you find the complement of set A dash. Complement of set A dash. Similarly, find the B dash complement of set B, right? You see now, you getting the RHS also, okay? And you see A dash intersection B dash. Once again see, okay, and you see, look at here, in both cases you see the De Morgan's first law is verified using the Venn diagram. These are the area, A union B whole dash and A dash intersection B dash, same area, right? Carefully see and also practice. Second property, second law of De Morgan's second law, also you can verify, which is A intersection B whole dash equal to A dash union B dash. Let's have a look. The proof of De Morgan's second law by property, using the property of the subset set, right? First of all, you have to prove A intersection B is a subset of A dash, A intersection B whole dash is a subset of A dash union B dash. Then you have to prove A dash union B dash is a subset of A intersection B whole dash, as usually using the property of subset. So you can prove De Morgan's second law. Have a look here. Here X belongs to A intersection B whole dash. It means X does not belong to A intersection B. That means X does not belong to A and X does not belong to B. It means X belongs to A dash or X belongs to B dash, or X belongs to A dash union B dash. It means A intersection B whole dash is subset of A dash union B dash. Similarly, it can be proved that yes, A dash union B dash is subset of A intersection B whole dash using the property set builder methods. In both the cases, we can get it. A intersection B whole dash is equal to A dash union B dash. Okay, and this is the proof of De Morgan's second law by example. Simplest method to prove any set theory. Example is the best method, lucid methods, but all the methods and process you must know. Particular method you cannot complete your mathematical knowledge and experience. You need to acquire the knowledge in every process, every concept, if you want to get details learning in your math. Okay, so let's see LHS A intersection B whole dash. Let's the set A, B and inverse L set. Let us find out A intersection B, which is CDE A intersection B, and A intersection B whole dash is E difference A intersection B. A intersection B, the element are A, B, F, G, H, K, M. Thus A intersection B whole dash is equal to A, B, F, G, H, K, M. Understand? Similarly, RHS A dash union B dash, which is A dash is equal to E difference A. So find out complement of the set A. Then find out B dash, which is complement of B, E difference B. Okay, this is the complement of B, complement of the set B, which is E difference B. And we can get A dash union B dash. The elements are A, B, G, H, F, K, N. Thus we get A intersection B whole dash element from the equation 2. A dash union B dash also from the equation 4. In both the cases, it is clearly understood that A intersection B whole dash is equal to A dash union B dash. Thus, A intersection B whole dash is equal to A dash union B dash. This is the proof of the De Morgan's law by giving example, simplest methods, lucid methods for you, and you can prove the property of the set theory using example by giving examples also. Okay, so De Morgan's second law we have to prove by using the Venn diagram, but it's A intersection B whole dash is equal to A dash union B dash, right? Let's see, let's have a look. Here A set, B set, and these are the element of A intersection B, common area. Okay, first of all, you find out A intersection B. This is the A intersection B. Then you find out A intersection B whole dash, mean complement of A intersection B. Complement of A intersection B, right? Okay, and the universal set E. Sometimes you can take the universal set by letter E, capital letter E, and this is the element of, see the shaded portion. Clearly understand, lucidly, nicely is explained. These are the area of A intersection B whole dash. It means it will never intersect the overlapping portion, common portion of A and B. Except the common portion, it will occupy other area, okay, which is clearly indicate and clearly understood the Venn diagram of the concept of A intersection B whole dash. These are the shaded portion of A intersection B whole dash. Okay, look at here, understand? Right hand side is A dash union B dash. We have to find out the Venn diagram. Look at the Venn diagram here. Here is the universal set E and here is the set A. Okay, and first of all you draw the complement of the set A by the Venn diagram by the shaded regions, and this is the shaded regions which indicate, it shows the complement of the set A, which is A dash. Similar manner, the complement of the set B, which is B dash, and which is already drawn by the shaded portion. Look at here, these are the shaded portion which shows the complement of the set B, which is B dash. Okay, now you have to find out A dash union B dash with the Venn diagram. Now this is the set A and this is the set B. Okay, now see and draw the shaded portion of complement of the set A, which is A dash. These are the, okay, the yellow lines indicate the complement of the set A. Is it clear? And these yellow lines cannot, do not overlap to the area of the set A. Similarly, draw the shaded portion of the complement of the set B, which is B dash, and these linings indicate that complement of the set B. Okay, it's quite interesting and easily you can understand how to show, how can you prove the De Morgan's law using Venn diagram. So this is the Venn diagram of A dash union B dash. Okay, and if you see in both cases, we see here the left hand side A intersection B dash. Look at the shaded portion. Similarly, the RHS A dash union B dash. Look at the Venn diagram. If you see closely, and both are the shaded portion are same, and which indicates that the A intersection B whole dash is equal to A dash union B dash. Okay, understood? Okay, so thank you, and here is an assignment for you, assignment 1. I hope you will try for the assignment. Here I have prepared some assignment for you, homework for you, which is necessary. Here is the assignment 2. Okay, and you can do it using the concept of operation of set theory. Here is the assignment 3. Look at the assignment here. Here is the problem based on the concept of union set and intersection set. There is another assignment 4. Okay, over the same concept, and the assignment 5. Okay, so I hope you have understood, and I must be thankful for your interest and eagerness towards your class. Okay, once again thank you for your interest and eagerness towards the class. Okay, I hope and you will give your suggestion and feedback. Okay, and also you will practice the similar kind of problem, and also you will try for the assignment. Once again thank you. Jai Jagannath.